Welcome to the Revo Mark I. Today, we're going to go over CAN bus termination, as well as power line bypass capacitors. First step, safety. CAN is a protocol for sending data across two wires in cars and other manufacturing environments. For Revo, we're using CAN to send throttle data to the motor controllers as well as the dashboard for the driver to see. This is the throttle node. Every blink of the LED is a CAN message that has been successfully sent down the line. This is a good CAN signal. Crisp, clean, binary bits. CAN is terminated on both ends of the wires by two termination resistors. These two termination resistors have to have the same resistance as the characteristic impedance of the transmission line they are terminating. This is really important in order to cancel out any of the reflections of the data coming back through the line. This makes it so that I can drive away without any interference from misbehaving transmissions. Let's see what happens if we remove one of the CAN termination resistors. Here it is, removed. Now let's see what that does to our CAN signal. This is the signal with one of the termination resistors removed. It still looks pretty good. It's a bit noisier than with both termination resistors, but you can still see that there are binary bits that are clean, crisp, and CAN-like. Now let's see what happens when we remove both termination resistors. This is the data with both termination resistors removed. It looks a lot noisier than before and a lot less clean. Because we're running at a 15 kilobits baud rate, it won't really affect our CAN bus, because all of our CAN transceivers can still read this data just fine. But if you notice, as the CAN bus tries to go back to its recessive state, it takes a little bit of time. If we were to go to a higher frequency in our baud rate, we would have a lot of trouble. CAN is a super robust system, so even with the removal of both termination resistors, it'll sometimes work. However, using both termination resistors makes it a lot cleaner and a lot more reliable, and allows you to go to a much higher baud rate.
Now let's talk about power lines. First step, safety. The low voltage sensing system on the Mark I runs at 5 volts. Let's see what happens when we input a 5 volt step into it. We can do that with a power supply. Notice how the signal spiked to nearly 9 volts and then oscillated down to 5. Let's model this as an RLC circuit, including the resistance and inductance of the lines as well as the capacitance between the two. We don't have any bypass capacitors installed right now, so the capacitance between the power rails is so low that the poles of the system are rather imaginary. Let's see what happens when we add some bypass capacitors. Once again, let's add a step. Here we see that we've added enough capacitance to dampen the front of the car, but the back of the car still oscillates. The spike, however, is much reduced. Hopefully, with this knowledge, our car will actually run.